Hey, this is Presh Talwalkar. Can you solve for x in the following equation? This problem was posed by Srinivasa Ramanujam in the Journal of the Indian Mathematical Society over 100 years ago. Give this problem a try, and when you're ready, keep watching the video for the solution. You might try and find an approximation in a calculator, a spreadsheet, or a computer program. You'll get that x is equal to about 3. In fact, x is equal to exactly 3. Let's see why. 3 is equal to the square root of 9. 9 equals 1 plus 8, and 8 factors out into 2 times 4. 4 can be expressed as the square root of 16. We now have a square root inside of another square root. We've come to the first iteration of this nested radical. Can we get to the next stage? Well, 16 equals 1 plus 15, and 15 factors out into 3 times 5. 5 can be rewritten as the square root of 25, and we've come to the next iteration of the nested radical. 25 equals 1 plus 24, and 24 factors out into 4 times 6. 6 is the square root of 36, and we've come to the next stage. In fact, I claim this pattern continues indefinitely. Therefore, we proved this infinite nested radical is equal to the original term, which is 3. But how do we know the pattern continues? If you take a look at the final square root, we always have the square root of a perfect square. We want to know, can we get from this term to the next term? That is, if we have the final square root being a perfect square, where the coefficient it's being multiplied by is 2 less than the perfect square, can we always take that perfect square and increment the perfect square and increment the term that it's being multiplied by? This is true. Algebraically, we start out with our original term and we expand out the square. We can then rewrite this as 4 equaling 1 plus 3. We now factor out n squared plus 4n plus 3 into the terms n plus 1 times n plus 3. And now we write a radical where we have the square root of n plus 3 squared. And this gets us to what we wanted to prove. So at any iteration, we can always get to the next stage, and that shows this pattern will continue. Did you figure it out? Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at Presh Talwalkar. And if you like this video, please check out my books. There are links in the video description.